Hi there, now we're going to take a look at how to solve what I would call a much harder inequality, purely because there are now two inequality signs. Now, I think the best way to look at this is to break it up into two separate questions. So what I mean is, look at the first inequality and write down everything that is involved. So this is like the previous video now. So x is on one side, number terms on the other side. So if we just separate that for the minute, and we've also got this one. So the middle part technically is with both. Now if we solve these independently of each other, so we're going to take away one from both sides, leaving us with that, and we half both sides, leaving us with this. Now let's go over here and do this one. So we'd take away one from both sides, and we would get that. And then we'd half both sides and we would get this. So what we're ending up with is 3 is less than or equal to this number, and this number is also less than 6. Or the number we're looking for is more than 3, and the number we're looking for is less than 6. So we can put these together like so. And that is exactly the same. So rather than separating it, we can now put them together. The question was put together, we separated it to make it easy, and then we rejoin it to answer the question. Now, of course, you could go ahead and list these to be 3, 4, and 5. Let's have a look at another one. Slightly harder because there's more x terms, but again, this middle bit is attached to both. So, take this one over to the left, take this one over to the right, and we will solve them. So, add 4 to both sides, leaving me with this. To get this x term on its own, I'm going to divide by 5, and that leaves me with 1 is less than or equal to x. And here, because this side has the most x's, that's where I'm going to collect them by subtracting 2x from here, and obviously the other side, leaving me with 3x, unchanged, that's gone, and we're leaving us with the 8. Add 4, so the numbers on the other side to the x's. So 3x is less than 12, so x must be less than 4. So now we have it again. 1 is less than or equal to the number, or the number we're looking for is more than or equal to 1, and the number we're looking for is less than 4. So let's pop these together, and we could write it like so. And again, if asked to list these, you could have 1, because it can equal 1, 2, and 3. It cannot equal the 4. So I'll just show you that in a little bit more detail. So solving it, in this instance, you don't always have to swap them. You can, if you like, do it like this. So 3n plus 2 or 3x plus 2, I have been changing what I've been putting here. It doesn't really matter. But so 3 times a number plus 2 is less than 11. So 3 times a number must be 9. When you get more fluent, you'll be happier not separating them. So if we take away 2 to both sides, that's minus 6. Take away 2 to this one, we get 9. Now this should be quite easy for you. So 3 times a number, so we only want one number, so we're going to divide it all by 3. So divided by 3, divided by 3, and divided by 3. Now we can go ahead and list them. So minus 2 can include, cannot include the 3, so we have it like this. And that's it. In the next video, we're going to have a look at what we call drawing inequalities on a number line.